Assalamu alaikum rahmatullah. Today we will discuss the Maxwell-Boltzmann distribution in kinetic theory. First of all, we will ask what is the probability distributions. Not all molecules have the average velocity of course. For a more complicated description, we need a velocity distribution function, which tells us how many molecules have any particular velocity. So the position distribution function does the same thing for the molecule's location in space. There are enough molecules in a microscopic gas sample that the distribution can be considered to be continuous. We define the probability that a value lies within an interval delta x around value x. Even this is the probability between x and x plus delta x. This rectangular bx times delta x is the probability that x lies between x and x plus delta x. So the probabilities are normalized so that the total value is 1. X must be something. إذا بالرياضيات إذا بدنا نعمل normalization ناخذ الانتجرال ل bx times dx equal 1 and from x1 to x2. So this is the definition of the probability for normalization. Okay, molecular speed in the container. Not all molecules have the same speed. If we have n molecules, the number of molecules with speed between velocity and v plus dv is defined by dn تساوي n f as a function of the velocity dv, whereas f(v) distribution function and f(v) dv, this is the same of the definition of bx dx. f(v) dv equal the probability of finding a molecule with a speed between v and v plus dv. Okay, when we have higher temperature, these higher speeds are more probable. إذا لما يكون عندي درجة الحرارة مرتفعة أو we heat the container and the container contains a gas or molecules, then we have higher speed. We can find the velocity of the molecule. So if we look to this figure, this is the PV and this is the speed. So at temperature 8 Kelvin, we can see the distribution. So it's smaller than the distribution for the temperature equal 300 Kelvin. This is the distribution. We can find the molecule with speed of between 0 to more than 1000. Why? When the temperature equal 8 Kelvin, we can find the molecule, the speed of molecule between 0 and less than 500 meter per second. So the Maxwell Boltzmann distribution, F L V, you can give it this function, this distribution, F L V, which equal 4 باي times M over 2 باي KT مضروبة في قوة 3 على 2 مضروبة في V square في exponential 2 minus M V square over 2 KT. So because it goes exponential, okay. إذا F VdV, this is the probability of finding a molecule with a speed between V and V plus dV. And the integration FLV dV between V1 and V2 is the probability of finding molecule with a speed between V1 and V2. And this is equal the area under the curve. This is the green area. So if we make normalization, this means we have to take the integral from 0 to infinity لFLV dV and equal 1. And we define the function, what is FLV dV, in the previous slides. Okay, so most probable speed, average speed, RMS speed equal Fm, most probable speed where FLV is a maximum, which equal the square root la 2kt over m, and the expectation value or the average speed v equal the integral from 0 to infinity v FLV dV, and after integral this we can get 8k, the square root, the 8k t over pi n, and this is the average speed. And the average square speed equal the integrals from 0 to infinity la v square la FLV dV, and this is which equal 3kt over m. And the root mean square speed, RMS speed, it's just VRMS, it's just the get the square root la average speed square, and which equal the square root la 3kt over m. Okay, then Maxwell Boltzmann distribution, which equal FLV dV equal 4 على جذر باي في m over 2k t, k is Boltzmann constants over قوة 3 على 2 مضروبة في v square dv exponential 2 مضروبة بالexponential minus mv square over 2k t. So where is this value v? This is the v maximum, which equal 1, and this is the average speed, and here also is the root mean square. So this is the curve or the distribution between FLV and v over v maximum. Okay. Now we want to prove the following relations. The average speed, this is equal the integral from 0 to infinity FLV dV, and which equal the square root for la 8 kpt over pi n. And also we need to the square velocity, also the integral from 0 to infinity لا v square قفل v dv, and this is equal 3kbt over m. And v are ms, just take the square root that's the v square. This is RMS speed. So how we can, or we, to prove this relation? So it's just substitute. We have to substitute f v dv and f v dv, okay, in this integral, and we have to integral from 0 to infinity. So we have useful integration to do this. We have this to prove you have to use this useful integration. Integration from 0 to infinity e over minus alpha x تربيع dx equal نص square root pi over alpha. And from 0 to infinity x تربيع equal minus alpha x تربيع dx equal 1 over pi square root pi over alpha cube. And the integral from 0 to infinity x القوة 4 equal minus alpha x تربيع dx equal 3 over 8 square root pi over alpha القوة 5. And also for x القوة minus alpha x, we can get 1 to L over 2 alpha, and for x cube equal 1 over 2 alpha square. So we have to do this integral simplified after substitute f v dv. We have to do this integral as the same of this relation. In this case, we have to make e القوة minus alpha here, e القوة minus alpha, okay? This is f v dv, okay? f v dv. In this case, we can make alpha تساوي m v square over 2kbt. Okay, then let us to do alpha equal minus m alpha. Okay, this notation can try to do some text if we can do it. Draw. Okay, let us to try if by this fit. Then we have to do let alpha equal m v square over 2k b d. Okay. We have, oh sorry, we have to do this alpha equal m over 2kbt. Remember, here is m over 2kbt. So we have 4 over the square root of pi في alpha قوة 3 على 2 في b square dv في e قوة ناقص alpha v square. In this case, we have, okay, in this case, after we make this simplified, then we can use, okay, this relation. It's become alpha x تربيع dx. This x equal minus alpha x تربيع, and we have v E القوة minus, we have alpha القوة 3 على 2, whereas the constant is out of the integral. في E القوة minus alpha v squared dx, and it's become in this form, and we take the results 1 over 2 alpha. Don't forget that whereas the constant is out of integral, and finally we have to multiply by the result of the integral. Okay. In summary of this lecture, we have a physical situation which is very important in kinetic theory, is the translational motion of atoms or molecules in a gas. The probability distribution for a given component of velocity is given by g as a function field x is proportional to exponential to minus m vx square over 2kbt. And we have shown that the corresponding expression for the probability distribution of molecular speed is given by FLV proportional to v square exponential to minus m square over 2kbt. This is known as Maxwell-Boltzmann distribution, or sometimes as Maxwellian distribution. So two important average value of the Maxwell-Boltzmann distribution are V equals square root kpt over pi m, and V square equal 3 kpt over n. So this is the end of this lecture, and thank you for your attention.